So this right here is our DSC, our differential scanning calorimeter. So to use this, it's mostly for polymer, it's mostly to study polymers. So you have a graph right up here, a sample graph of what kind of data you obtain from this. So you use this to heat up the polymer and measure the heat flow. That way you can find like the melting temperature, crystallization, and glass transition temperatures. And you can also figure out the delta H associated with these transitions. So this requires significant sample prep. All the samples have to be heated up in these little sample pans, which will always just be on this shelf here. So then I'll just remove the dome. So you have to use gloves when you're handling these because thermal instruments are very sensitive to things like finger oils. So you would just have your pan sitting on there with your sample, and you run the instrument like that. You can't have it touching the chip, which is this blue part, directly. So you need to be very careful with the chip because it's very delicate, and if it gets broken, we have to buy a new one.
Looks like we have a new one.
That one's broken.
Oh, never mind.
We have one replacement, but we don't want people to break this stuff because it takes forever to get here. So then you want to make sure you weigh your pan. So once the weight settles, tear it and insert your sample. For your data to be useful, your sample should weigh at least around 10 milligrams. So you can see that one's only about 5 milligrams. So we'll need to get a bit more. You also want to make sure that your sample's as flat as possible because the better contact it has with the ground, the better thermal contact it has, the better your data is going to end up being. So this obviously is just some round 3D printer filament, so we're going to try and squish it down to improve our thermal conductivity. So you can see now that's a bit flatter, which should make it test a bit better in the machine. So I just carefully pick that up and set it in our sample holder. Now I've got about 14 milligrams, which is acceptable. So I'm just going to take our sample pan out. So the other thing we can do to improve thermal conductivity so that we get better data is to crimp the pan. So to do that, we're going to take one of these lids, which it will say on the top, lids. We'll put that on top of our pan carefully so that sits just inside and is level. There we go. There we go. So we're going to pick it up and we're going to move it to this press here, which is for crimping. There's also a second press right there, which will do an airtight seal, but we want cover that today. Then you want to make sure your sample is centered in the press. Otherwise, it won't crimp right. You pull this bottom part down and you pull the lever. So you can see now this is crimped. So that should improve the contact our sample has with the bottom, which will give us better data when we run it. So moving to the DSC, to turn it on, we just hit the switch at the back. And we'll open up the chip DSC software. And then before we can actually test our sample, we have to run a correction curve with an empty pan. So this needs to be as similar to our sample as possible. If you're really concerned about your data, you should measure the weights to make sure they're the same, but the sample pans are pretty consistent, so it's not completely necessary to do so. So just set it in here carefully, crimp it, and you set it on the chip. Try and get in that little indent in the center so it's nice and level and it's good thermal contact with the chip. And once that's in place, carefully put the dome back on top to protect it from any air currents. And now the password to the software is enter. There is no password. So then we'll start in general settings. Crucible is our pan. It's made out of aluminum. So then we'll give our test a name. Then this is our weight, our sample weight. We are starting with a correction measurement, which means there's no sample, and so the weight is 0 milligrams. So then we can select our folder hair. And then we go to temperature profile. This is where we'll set the specifics of our test. So you can see the calibration we're using is for 50 C a minute. So all of our rates are going to be set at 50 C a minute, otherwise it won't be accurate. So we'll start by doing 50 C a minute till we get to 200 C. Once we're there, we'll make a 1 minute dwell time, which means it'll stay at 200 for 1 minute. And afterwards, we will cool back down to 25 C at the same rate of 50 C a minute. So this right here is the final temperature of the step, the rate, and the amount of time it spends at the ending point. Over here we can add or insert segments, and also delete segments. And here at the bottom, it will show you the temperature profile for the test you're starting. So once you have all of your settings selected, you can hit start measurement at the top. Oh no.
said the temperature measurement was unexpected and it went to idle.
This is the silence. Whew.
How did you
That's
fix
good.
it?
Okay, so it just wasn't connecting to that properly.
Oh, okay.
And so it thought the sample temperature was like negative 200 Celsius, which made an error and stopped the recording. You can just stop. This is going to take like 10 minutes. We'll just skip to the end of the. So once it finishes up, you have your whole graph filled out and it'll say idle here. So it's now saved your correction measurement. You can go back to current values. Sorry, to setup. And this time under general settings, we will do sample measurement. And if you remember right, our sample was 13.9 milligrams. So we'll put that under the weight. Now we'll want to go to our folder. So select the folder you want it to save to, which should be a folder with your name on it. Then down here at the bottom, you'll select your correction curve, which is this one right here for us. So we'll load in the correction curve so that it will be compared automatically to our sample. So this is all the same as it was last time. We need this to be exactly the same as our correction curve, otherwise it won't work. So once we've got our correction curve done, we can just take the empty pan out, pick up our sample carefully, and move it onto the chip. So you want to make sure it's in that slight indent in the middle and that it's sitting as flushly as possible to maximize our thermal contact with the chip. Then we go ahead and put the dome back on and we start our measurement. Okay, it says it's idle, so it finished the measurement. So now we can go ahead and close out of our graph here. To analyze the data, we go to evaluation, which should be right next to the DSC shortcut. So just go to default, and there's also no password. You just hit enter. Load the curve and select our sample. So it will give you the graph. You have all these tools up here on top to help you analyze it. For instance, you can measure
Fix this, then go back to, for instance, you can measure.
For instance, you can measure the enthalpy of different peaks and troughs. It'll tell you the temperature at which it starts, the maximum, the overall enthalpy. So this software should give you everything you need to be able to analyze your data. So once you're done with all of that, you can
Go back to you can save it.
Once you're done with all of that, you can save it. And once you've saved your data, you can go ahead and exit out. And remove your sample from the DSC and dispose of it however is necessary and safe for your particular sample.
Switch off the.
Then you just switch it off at the back and log out.